Probably fair to say that if you've got one of these, then you've also got one of these. Yep, the good old Commodore 64 power supply. These things have got quite the reputation these days. It doesn't matter what the problem with your machine is, you can guarantee that someone will diagnose the problem as being a power supply. And the infamous brick of death has claimed another victim. Now, I'm not going to spend all this video discussing the reputation of a power supply, but rather what we can do about it, potentially destroying our precious Commodores. Well, the easiest thing is to go out and buy a modern replacement. But if you're like me and you can't help wanting to do it yourself, then keep watching, as that's what we're going to do. But before we get started, I need to point out that we're going to be working with mains voltages, so be careful. And if you're not sure,
get a responsible adult to help.
So what we're going to need to build ourselves a Commodore 64 power supply. Well, first and foremost, we're going to need a power supply itself. So for this, I'm going to use this Meanwell RS155. This is a 3 amp power supply and more than enough to power a Commodore 64 and a few accessories. But the Commodore power supply also needs 9 volt AC. So we're going to need a proper transformer. This one I picked up second hand, although I don't think it's had a lot of use, but that'll be fine for our AC. And we're also going to need a box to keep it all in. So I'm going to use this rather spangly red number here. It's a little bit large for the purpose, but that's not a problem. It'll help us lay things out inside a bit easier, and it'll give a bit of room for air to circulate. We're also going to need a few other things. So we're going to need some switches, some fuse holders, not a bad idea. Oh, we've got some rubber boot for the cable. We've got an inlet socket there for the power. Now a DIN socket, that'll go into the side of the Commodore, and of course a bit of cable. Okay, so before we start wiring everything together, let's just take the lid off the box and have a think about how we're going to lay stuff out inside it. See where the parts will fit. You got plenty of room. Now we can mark out where the pieces are going to go. We need to drill some holes in the bottom of this to mount all these parts. We can use those holes we marked. Mark out where the holes in the bottom of our power supply are. Happy days. So I think in the front we'll have a power switch, and then we'll get the cable to come out below it. I think that's probably the best plan. Right, and around the back we're going to need to mount a couple of things. We're going to need to mount this socket. That's going to go over on this side. And we're also going to mount this switch. We'll get onto this a bit later, but this is a voltage selection switch, so we will put that somewhere else. Where should we put it? Right, we'll have to get a bit creative with these. We'll drill some holes, file the rest out. Okay, so much drilling and filing later, we've now got our case in such a place where we can start mounting all our parts in it. So let's crack on with that. I'm going to use I'm actually going to use rivets to mount the transformer in. So I'm going to leave that one till last. So they'll hold it in nice and snug and won't come loose. Okay, that's all the parts mounted except for the transformer that we'll leave to last because we're using rivets. So we can start thinking about how we're going to wire it up. How's this go? Goes like this. Oops. So, incoming mains here. It's going to go through the fuse to the switch and off to the two transformers. Well, the transformer and the power supply. Out from the transformer and the power supply, out the front to your Commodore 64. What could be more simple than that? Well, plenty of wiring to be done. So let's just crack on. Okay, first things first, let's wire the incoming mains to the fuse. Right, as these are the mains, we'll pop a bit of heat shrink tube over those connections. That's a little bit of belt and braces. Right, on this end we're going to add a crimp. To go on the back of the incoming socket. Twist it round so we don't get any whiskers. And this end we'll solder onto our switch, again with a bit of heat shrink tubing that we shan't forget to put on first, over the wire that is, because otherwise we'll be in a pickle. Okay, so we want the output of that to go into our 5-volt power supply and our transformer, which lives over here. Right, so now we've wired in the switch and the fuse. These will basically go one to the 5-volt and one over to our transformer. Leave a bit of slack in so we can put it all together. Tidy all the cables up at the end. And what I'm going to do next though is wire in the earth connection. So to be safe, what I want to do is I want to wire the earth connection from the incoming supply over to transformer casing, the 5-volt and the upper part of the case. Now all this should be connected together via the screws, but we'll wire it in properly just to be a bit of belt and braces. So on the top part of the case, I do have to drill a small hole so we can create an earth point on the top half of the case, because actually the top half and the bottom half of the case are held together with these plastic end pieces, so there should be no earth continuity there, but we'll make one. So earth is next. So we'll wind all these together and we'll put them in a crimp. we'll put a ring end on this so we can connect that to the transformer. We'll fix our transformer in. I say I'm going to use rivets. They should be nice and sturdy and not come loose. But we're going to connect that earth point up with a rivet. If you haven't got a riveter, feel free to use nuts and bolts. And at some point there'll be a bang as the rivet comes loose. So there's our first rivet. We'll just go around the other side. I'm a bit worried that I've mounted this power supply in here and I'm not going to be able to get to the screws on the front. Let's find out. I think it should be okay. Oh no, it's a bit of a dodgy angle. We're going to have to loosen the screws on the bottom here just so we can get to the screw terminals. We can also do our live connection. I'll have to excuse my constant switching around of the earth and ground terminology. I know what I mean, honest. When you start getting into doing this wiring, you suddenly find yourself getting into a big bird's nest of wires. Hopefully we're then going to tidy up at the end. So we need to run the neutral connection over from here on this incoming socket, not only to the transformer and the power supply, but also to the bottom connection on this neon switch. So the switch will light up when we turn it on. This one's handily marked on here, so you haven't got to worry too much. Perhaps you can't see, but handily marked, which is live and neutral, so you don't get yourself muddled up. So our next job is to wire in the incoming supply to the transformer. I've done the 5-volt supply. These neat little supplies will accept between 100 and 240 volts anyway, so we don't need to worry about this. But with the transformer, this is a particular type known as a dual primary transformer. And if you can see very carefully down here, it says that it's got 2 connections, both from 0 to 120 volts. And this can be wired in 2 ways. Either you can connect it in for 120 volts, or you can connect it for 240 volts, which is the way it's been wired now. So someone has previously used this transformer. So you basically bridge the 2 primaries together in a series connection like this. So the negative here, and then this is kind of the positive of this connected to the negative, and then you'd connect the positive over here. So this is wired in series for 240 volts. But if you want to wire it for 110, 120 volts, you wire it in parallel. So what we need to do is we need to cut this wire that someone's put in here, and then we can use this switch that we've installed on the back to switch it between 120 and 240 volts. Now, if you were doing this yourself, I would not bother with this at all. So just connect the wire in the middle, or just connect them in series or parallel, depending on what you want. I'll try and put a diagram up there, maybe show you what to do. Right, so let's disconnect this wire in the middle here. Let's just cut it out. So I've had a bit of a scrawl, jotted down how I'm going to try and wire this up. So what we've got is we've got our incoming supply from the plug, we've got our transformer, and we've got our switch. So this is a dual pole, dual throw switch. So in the bottom position, in the 110, 115 volt position, these two poles are bridged, and in these two poles are bridged. And in the up position, 230, 240 volts, these two poles are bridged and these two poles are bridged. So if we take the upper position, 230 volts, all we need to do is we need to bridge the two middle connections and make sure we haven't got anything else going on. So all we're going to do is this wire is coming down from here and it's going to be bridged across there and back up to here. Now we push the switch down into the 110 volt connection. What we need to do is connect 0 volts to here and 120 volts to there and not have any connection in the middle. So the 0 volts comes here and it will go across this bridge here and over to our little loop up to the other 0 volts. And the 120 volts will come in here and cross this bridge here and over to there. So these ones are not connected, so that should do the job. Okay, so we're going to wire our voltage selection switch. We're going to start off with bridging these two pins with our, found a bit of a offcut of a component leg. Following our diagram, let's go across and make the connections to the transformer. So, connections made. Should get our multimeter out and test it. Okay, we're about ready for a power up test. Now we have all the main side connected, but I just need to pop a fuse in down there. But I'm going to put it in one of these little plastic covers because I don't want him to get a tingle over the mains supply. As always, we've got the top open for a power supply. We've never tested before, so let's take some care. I've just put some tape over the top of these terminals. These are the terminals where the windings go into the transformer, but they'll be live at mains voltage. What we'll do is we'll plug it in. We'll make sure we've got our switch set to our local voltage here, which is 230. So we'll plug it in. The switch is off, and then we should be able to check. So we've got our meter set to the right thing. So we get the leads around the right way. So we should see that we've got some line voltage, 142 volts today. So we should see that on the fuse, which we do, but we shouldn't see it over here. We do not. So that's good. The power is coming in, going through the fuse, getting to the switch. So theoretically, we flip the switch on the front and it all should power into life, or it will blow all the fuses and go up in a puff of smoke. We shall see. Also, we should get our little our neon switch come on. Well, we've got a hum. That's a good start. Transformer. Right, we've got LED on our power supply. So if we just knock down our measurement here, we should be able to see a voltage on this taking care. Got 10.5 volts coming off the transformer. Dual secondary, so that's about right. So transformer's doing its thing. If we just put it, knock it over to DC, we should see our DC output. I've got the leader on the way. So yeah, you can see that is now showing 5 point something volts. Is adjustable on this supply. I'm going to wire the two supplies up to the fuses. So you can see down there, there's 4 output lugs on this transformer. It's a dual secondary as well, so we're going to wire those 2 in parallel. They're the 9-volt supplies, and we'll take the feed from one side of that into one of the fuses, and the other one will just go straight out on the wire. And same with the 5-volt supply, one of them will go through the fuse. So first thing we need to do is parallel these outputs on this transformer. I made my job difficult for myself now because it's right hidden under here. So that will go round to there, and the other one will go round to the other side. Okay, so that's that one, and then we'll connect this yellow wire into this one of these fuses over here. Okay, next step, connect our output of our 5-volt to input of this 3rd fuse down here. Right, there we go. So that's all the fuses wired in. Now when we connect the cable in, we'll have 2 onto the fuses and 1 onto the transformer and 1 onto the negative output of the 5-volt. So let's feed this through now, shall we? We're through. Right. Make sure a little bit of the sheathing comes through, and you can see it just there, because we'll add some strain relief to that before we're finished. First of all, let's do the hard one, which is going to be the green one. Needs to connect down to that transformer. The next job is going to be wiring up our DIN connector for the power plug. I hate wiring these things, especially when we're talking about oversized kind of cable for power plugs. So much so that I've brought in the help of the good old helping hands. So first things first, make sure you put the boot over the cable. Don't wire it all up and then find you haven't done that bit. My tip is for these, if you want to use the helping hands, is put the crocodile clip on the pin that you want to solder, because it will suck away some of the heat when you solder it so it doesn't melt. Just get the multimeter out on continuity and make sure we haven't shorted anything out. Okay, so we should check the other one. Worth checking the pin next to it as well, because that's the one most likely to be shorted out, right? Yeah, I think we've created a short as a case. Okay, yeah, it's a slight thing with these bottom AC lines. When the screw goes in, it's just touching the bottom of that wire, so make a bit of adjustment. So much swearing later, finally have a properly wired socket with no dodgy shorts or anything else bad going on. So now is the time to introduce you to this complete contraption. This rather rough and ready piece of junk is actually something I put together many years ago to test Commodore 64 power supplies under load. So there's just a couple of big resistors that are gonna, let's try the power supply out. Right, let's fire up and see how we do. So this is testing the AC line, so we should get around 10 volts. That's about right. We lose about half a volt under load. thereabouts. Let's try the 5 volts. Right, test it under load. Okay, we get dropped us down to just under 5. So let's leave it under load while we tweak the voltage. Just over 5, that'll do nicely. Right, so it's been on a good while. This thing is really roasting hot. 5 volts is still steady at just over 5. Let's just test the AC just to make sure nothing bad has happened there. It'll drop down a little bit. That's fine, just as it's warmed up. The normal thing to do these days is to use a lot of cable ties to tidy all this up, but I'm going to be a little bit different. I'm going to use some lacing cord. It's an all new hobby of mine. I am going to use one cable tie though. I'm going to use it down here on this outgoing cable, just as a little bit of a strain relief. So we're just going to put that on the back of there, do it up nice and tight. So the lacing cord, I am no expert at this, but we're going to give it our best shot. Try and make the knots relatively even along the length of it. Tie it off. Short lengths already, those other bits. So that's just tidied up the top of it. So I think all we need to do now is connect up our lid. Right, I'll just tighten that up, pop the lid on, and we're about done. So there we have it, our nice little Commodore 64 power supply. Now this particular one, there's a reason why I've made it with a voltage switch and stuff, because it's not just for me. This one is going to be auctioned off by my good friend Lee from the YouTube channel More Fun Making It. So he is going to have a fabulous charity auction this year, and this will be going out with one of the amazing Commodore 64s he's put together. So now all I've got to do is go and make another one and then send them to Lee. So watch out for it, and we'll see you again soon on the Rage Against the Retro channel. If you've enjoyed this, you know what, like, follow, subscribe, all that stuff. See you again soon. Bye bye. Woo! Ah, yeah.